having a look at the 2022 paper number 2 Tech Active multi-choice questions in this one. So obviously the Tech free one, we didn't have access to the calculators. This one is going to be calculator heavy, and you really need to be able to know the features of your calculator and how to use them efficiently to be able to get through this paper with an amount of time to work on the complex questions. So we've been given an equation for the position of a particle as x equals cos 4t, where t is the time in seconds, and we want the velocity of the particle when t equals 5. So probably the quickest way to do that is to pop that one in just as y equals cos of 4x, and then graph it. I've got my calculator in radians already, so I've got my graph up there, and I want to know the velocity, so it's going to be the derivative when t equals 5. So I can just use second trace and use that number 6 there, put in when x equals 5, and realizing that I haven't got my window set up big enough for that, so I'll change that to go up to x equals 6. Graph that again. Then I can do my second trace 6 and put in 5 this time, and I get negative 3.651711 there. So then I can look that is D as my answer. Now another option would have been to do the derivative and then graph that and use your second trace 1 to find the value, but it's quicker just to pop that in and do that straight away. Question number 2, identifying the correct features of the function f of x equals x e to the x. So to start with, I just put my y equals x e to the x into my calculator, and then I used my second trace to find out what values the derivative had at -1. So that gave me 0, which meant I could then narrow it down to the top 2. Then I needed, for my second derivative, obviously I need at least the derivative to then use that calculator function on there. So I needed to do the derivative of x e to the x there. So using my chain rule, I've got my u equals, I'm going to switch to black, sorry. U equals x, u dash is going to equal 1, v is equal to e to the x, v dash is equal to e to the x. So then my u dash v plus v dash u is going to be 1 times e to the x plus v dash is e to the x times x, so I'll just write x e to the x there. And then I can pop that into my calculator and find out what the value of the derivative is, which would then be the second derivative. So popping that in here, I've got my e to the x and then plus x e to the x. Graphing that, and then I want to sub in to that, just waiting for that graph. So I want to do my derivative when that's equal to -1, because that was the second derivative. So if I've got the derivative function there, then if I do the derivative of that, that's the second derivative. And when I pop that in, I get 0.36, which is obviously greater than 0. So then that tells me the answer is going to be B. So then we go on to question 3. Now question 3 is a little bit of a funny one here. So we've got the derivative of the function is given by sine x to the power 3 for the domain -1.8 to 1.8. The number of points of inflection the graph has on this interval is. Now, I think probably the easiest way to go about it, because our points of inflection are when it cuts the exact, like when the second derivative is equal to 0, we're looking for where it cuts the x-axis. So if we find the second derivative, that means we've got 3x squared cos of x cubed. If we pop that in there and look at the graph for that, then we can look where it's cutting the axis. So popping that into my calculator, getting my graph there, and I want to then set it, my window, which I haven't done, to go between -1.8 and 1.8. So when it's finished doing that graph there, I will change that negative 1.8 to 1.8. And then we can go along and just count how many times it crosses. So we've got 1, 2, 3, 4 times that it crosses the x-axis. So our answer is C4. And it was a little bit, I feel like it was a little bit of a trick one, because when you look at that graph, you do see that turning point there, but it's not crossing the x-axis, so technically not an inflection point. Going on to question 4. We have got our distribution for a sample proportion has a mean of 0.15 and a standard deviation of 0.0345. So we need to find out the sample size. So we're going to use our standard deviation is equal to the square root of p outside of 1 take p over n. To solve this one, we've got the standard deviation of 0.0345. We've got our p is 0.15 outside of 1 minus 0.15 over n, and it's the n that we're solving for. So what we'll do is do the square of that to start with, which is going to give us 0.0119025. And then that leaves us with 0.1275 over n when we expand that out. So just bringing that n over here, 119025n is equal to 0.1275. So then to get the n on its own, we'll do the 0.1275 divided by the 0.119025, and we get 107.12, or approximately 107, as the answer there for C. Then we've got the continuous random variable, and we want to work out our standard deviation. So for the standard deviation, we need the expected value, or the mean. So we need the f of x, so x cos x there. And we want to do the integral of that between negative pi on 2 to pi on 2 to get that one. And then we want to go between negative pi on 2 and pi on 2 of x squared cos x to get the e of x squared. Now when we do this one, we're going to get 0 when we do this one, and you can do that on a calculator. Just put it in, graph, and do the second trace 7. When we put this one in, we get 0.467411. So we would do that one, take that one squared, and then the square root of that. So our variance is just the 0.467, and when we do the square root, we'll get the 0.68366, which is our B. Okay, going on to question 6. We've got a stall at the school fete sells cups of lemonade. Assuming that the amount of lemonade in a cup is normally distributed with a mean of 60 mils and a standard deviation of 3 mils, 80% of the cups contain more of. So when we look at our little picture here, we've got our 60 millilitres, and we want to look at where 80%. So drawing that in, if that is 80%, what number will give us that? Now, we've got two options. Obviously, calculators have improved a lot since I first started teaching this, and even from when I was doing it at school. So my go-to would normally be, because I couldn't work out that side of it, I would do 20% and find out what that value is. However, you now have that option on your calculator to choose which tail you're looking at. So when you do your second vase, we can do that inverse norm, and we can put in there our area of 0.8. We've got a mean of 60, a standard deviation of 3, and then we can tell it to look at the right side of it. Or if it was the middle 50% or something like that, we could use the center. So we have that option now. And not sure, oh, there we go, enter. And we get 57.47, which is B. So yeah, we could have gone the other way and put the 0.2 in and solved it that way. But because the calculators can do extra now, we've got that option. Question 7 we've got is we've got a velocity of 2 ln of t plus 1, where t is the time in seconds since the marble passed through the origin. Determine the distance from the origin the marble has rolled in 4 seconds. So distance is your integral of velocity. So we just need to pop this in and do the integral on our calculator. So if we pop that in to our y equals, and so we want 2 of ln of x plus 1. Graphing that, I may need to change my window so it includes the 4 there. Doesn't look like I'm going up to 4. So I'm just going to make it to 5 so that that includes it. And then I'm just going to go second trace and my integral between 0 and 4. And that gives me the 8.09, which will round, 8.004, which will round to 8.09, which is the answer D. Question 8. We have got determine the equation of the asymptote of the function f of x equals log 9x minus 3 minus 4. So our asymptote is obviously looking at this part of our equation. So when we would get a 0 in this bracket, so to get a 0 we would have 3 minus 3, so x equals 3. So that's a nice quick one to do there. X equals 3 was our answer. Question 9, using our sine rule, because we have to find the side AB. So we'll put a little x there, and we are given its corresponding angle, and we also have A with its corresponding side. So we can say that 12 on sine of 30 is going to equal x on sine of 37. So then sine of 37 times 12 on sine 30 is going to equal x. And when we pop that into our calculator, remembering to change your calculator back into degrees because we've been working in radians a lot, and we get 14.44 as our answer, which obviously is B. Okay, question 10, last one on this paper. The solution of e to the 2x minus 3 equals 42 is, and I love this one, it's my favourite type to do, because we are just popping in there e to the 2x minus 3, and then we're popping in the 42 as its own line, and then we can just see where they cross. So we can graph those two functions and see where they cross. Obviously I need to change my window because I haven't gone up to y equals 42, so I'm going to change that to going up to maximum of 50. Now we should be able to see where they cross. And then we can just do second trace. We want the intersect, and there's only one that we can see on the screen, so that gives us 3.36, which is approximately 3.37. And that is the last one on that multi-choice paper. Hopefully that's helpful.